Hey guys, in this lesson I'll be just basically covering everything we've done so far in trigonometry, which includes labeling sides of a right angle triangle, using Pythagoras to calculate different sides, and using trig functions to calculate different sides and angles. So let's just start off with labeling our triangle. We know our triangle is always labeled like this, and we can apply Pythagoras to this, where we know that c squared is equal to a squared plus b squared. So here's a, which in this case is our adjacent, and then here's b, which is our opposite, and we then have our hypotenuse, which is c, or directly opposite to the 90-degree angle. So that's for labeling, right? But it depends on where theta is. So say if theta was here, then b would become our adjacent, and this would become our opposite. So that's pretty much how it is, but typically it's like this here. So now I'm gonna put up one problem, just a Pythagoras problem, and I'd like you to rearrange the equation and solve for x. Okay, so I'd like you guys to solve this basic problem here by applying Pythagoras, and then I'll solve it also. So pause the video here and give this problem a go. Okay, so let's move in. So we know that this is, let's just label our triangle. We know that this is A, this is B, and this is C. So we know that Pythagoras theorem states that c squared equals a squared plus b squared, but in this situation we have b squared to solve for. So henceforth, b squared equals c squared minus a squared. That looks like a 9, a squared. And then we do basically c squared, which is 12, and that is 144 minus 16, and we get 128. And then what we must do is find the square root of 128, which is 11.31. So if you got x to be 11.31 units, then well done. That's Pythagoras pretty much. So now I'm gonna put up a problem involving a trig function. So let's go here. We have our right angle triangle. I'd like you to calculate this length here, and I will provide you this length here. So basically you must be able to apply SOHCAHTOA and also label your triangle, and then we'll solve it together. Okay, so first of all, let's just get into the working out. So we have our opposite, we have our hypotenuse, which so opposite hypotenuse is sine theta. So sine of 46 bracket opposite over hypotenuse, which is x over 12, and then sine, and then what we're going to do is we're going to write x equals sine 46 bracket 12, and then x equals sine 46. And if you got x to be 8.63 units, then well done, you've got that part correct. Okay, and then I'll put up one final easy problem, a medium level problem, which requires you to calculate the angle. So I'm going to draw, Alright, so I'd like you guys to calculate angle X, and I'll give you these two sides here. So I'd like you to calculate angle X and round your answer sensibly if it is meant to be rounded. So yeah. Okay, so let's just get into the working out. So we have opposite, we have adjacent, we use tan inverse, right? Because we're calculating the angle. Tan inverse bracket opposite, which is 12 divided by 7. And evaluating that, we get, if you got x to be 59.74 degrees, well done. That's pretty much it for trigonometry and what we've covered up so far. So we have our right angle triangle. That's very right angle. And this is A, this is B, this is C, and we use the rule to calculate hypotenuse, or Pythagoras theorem is c squared equals a squared plus b squared, and then for the trig functions we have sine, cos, tan, and that is for that is one angle and one side, and then we have sine inverse, cos inverse, and tan inverse, which is used to calculate the angles. So basically that means two sides and 0 angles. So that's pretty much it for what we've covered so far. And that's pretty much what there is so far to right angle trig. So later on we'll cover some non-right angle trig, which will cover the sine and cosine rules. And yeah, but pretty much that's it for this lesson. Thanks. Bye.